Salam and welcome everybody. Today I'm going to start solving some past paper questions in organic chemistry. So let's start with the first one. By the way, this year is 2016 variant 1, paper 1. Okay, so let's start with the first one. The question says, the diagrams show two different compounds. What is the total number of structural isomers, including compound 2, that could be formed by adding a second methyl group to ring of compound 1? So generally speaking, if you're going to go to the compound 1 here, we're going to add a methyl group. So this methyl group could be here, or in here, or in here, or in here, or in here. So we change the structures only in this case. So if you start counting the number of possible isomers that you could have a compound when methyl group is in here 1, or when it's in the second carbon, or third, fourth, or fifth carbon. And you just notice that compound 2, which has a methyl group that is in the second carbon, is included in here. So the total number of isomers that you could have is 5. So we could have two possible answers, C or D. All right. The question says also the number of pi electrons. Okay, so here we're asking about pi electrons. We're not talking about pi bond. So the pi electrons in here, we have 2 pi electrons and we have 2 pi electrons in here. Then the total number is 4. So if we go here and just notice that the answer is D. Okay, so let's go to the second one. The question 21 says, the structural formula of compound X is shown. Yeah, this is compound X. What is the name of compound X and how does its boiling point compare with the butanoic acid? So first of all, you have to look at this compound and you just notice that it's an ester. Okay. So we used to name esters like, I just want to recall that, like CH3, you have double bond, for example, O, and you have CH2, CH3. So in this case, once you want to call, or let's say name this ester, we will take the first part in here, which is after the oxygen, and we call it ethyl. Okay, so once you have, for example, 3 carbons in here, you can call them a propyl. If you have 5, you can say pentyl. And then we go to the second part in here, which is the carboxylic acid, and it's called ethanoate. So this is the name of how to name esters in this case. If you want to translate this compound here, you could say how many carbons are after oxygen. You can write it in this case, like, yeah, and you have O, here we have CH2, you have CH2, CH3. So we draw this in this form, just like to make it easier if you want to understand it. And then you can notice that the carbons that are after the oxygens is 3 carbons. So in this case, we can say your compound is a propyl, okay? And actually, this group looks like aldehyde, but in this case, you have to keep up with this because it's an ester, and you have only 1 carbon, and this is called methanoate. So this is the only case that you have methanoate that is not bonded to any carbons in here. So once you have C double bond, H, and you have oxygen, and here we have R, this is definitely ester. So you have to call this this type of R that comes from alcohol, like ethyl, propyl, hexyl, whatsoever. And you have to look at this part in here and just count the number of carbons. Here we have only 1 carbon, then it's methanoate. So if you look at the answer, 2 possible answers, you have a propyl like in C and D. Okay, so let's go and see what is the second thing here. It says that the boiling point of X. The boiling point of X. Once you were asked about the boiling points, you have to relate them to the intermolecular forces like hydrogen bonding, van der Waal, temporary, like this stuff. So we're going to compare the boiling point of this compound X with butanoic acid. So first of all, you have to identify the type of intermolecular forces that are present in this compound, like X. The type of intermolecular forces, we notice that you have oxygens and carbons, and the type here is permanent. It's permanent dipole, okay? And The other compound that you will compare it with is butanoic acid, and you just notice that butanoic acid, it's a compound that contains hydrogen bonding. We have hydrogen since you have OH group. So you notice that hydrogen bonding is stronger than the permanent. It's way stronger. So we could say that in this case, the X compound here will have lower boiling point than butanoic. So the answer is D. Okay. Question 22 says, which pair of reagents will take part in a redox reaction? So first of all, you will look at what is the redox reaction. It's a reaction once you have a change in the oxidation state. If you look at the reaction A, if you have a reaction of this, then you will have a addition, electrophilic addition. You notice that this compound in here contains double bond, and the possible double bond could be between these two carbons. So actually this compound looks like this, CH3, you have C double bond, and you have H in here, and CH2. All right, so you have double bond. So once you add bromine in here, it will give you a compound that looks like this, CH2, and you have Br in here, and you have CH, let's say here we have Br in here, yes. So you will have a compound, two bromine atoms that are bonded to each carbon. So if you look at the oxidation number of bromine before it reacts, it was 0, okay? But once it reacted, it becomes -1. Where do we get -1? According to the redox reaction rule, it says that once you have a bromine that is not bonded to any oxygen atom, then it has oxidation number of -1. So as we can see here, we have a change in the oxidation number of the bromine. Then it's a redox reaction. Then the answer is A. Okay, let's go to 23. It says that the first propagation step in the reaction between methane and chlorine is shown. Okay. Before we start, let's say, completing the questions, you have to remember something about the propagation. First of all, it's a technique that we can make a substitution reaction. Once we make a reaction between halogen and organic molecule, the propagation step indicates that you have a radical and a molecule. Okay, so the radical is mentioned here, as we can see, which is Cl radical here. It will hit and catch. So here we have a carbon, which is methane. We have methane and we have a radical in here. So this radical will come and attack one of the hydrogens and take it, and that's why it appears as HCl, and leaving the molecule as a radical. Okay. It says that how many different first propagation steps are possible in the reaction between pentane, okay, C5, yeah, and the chlorine. How can I translate this word? First of all, you will draw the pentane. We have 5 carbons, right? 1, 2, 3, 4, and here we have 5. And each carbon has a certain number of hydrogen atoms. So once you have a reaction between a chlorine, which is a radical in here, and this is a propagation step, the chlorine is mentioned as a radical, it will hit and catch one of the hydrogens. So this chlorine radical could attack the first carbon and just take the hydrogen in here, or it could attack the second carbon and take this hydrogen in here. And it could attack the third carbon in here and just like have it. So according to what we have, we could have 3 possible radicals. So we could have a radical number 1, which has like 1, 2, 3, 4, 5. You could have a radical on the first carbon. You could have 1, 2, 3, 4. You could have a radical on the second carbon, or you could have a radical on the third carbon. So you have different propagation steps, as we can see. The number of propagation steps that you could possibly have is 3. So the answer is B. All right, let's erase all of this stuff in here. Okay, the question says alcohol Y gives a product Z after oxidation. It gives positive results with Tollens reagent. So you just remember that Tollens reagent is for aldehydes. Okay, you'll possibly have alcohol that it changes to aldehyde, which is surely primary alcohol. Primary, sure, this is sure. And let's complete it here. And with 2,4-dinitrophenylhydrazine reagent. Okay, which means that you have a carbonyl compound. You could have either aldehyde or ketone. But this is the most important information. So it says that you have a compound, which is alcohol, and you just make oxidation, you get aldehyde. It gives positive test with Tollens reagent. And it says that now what could be the identity of this alcohol? So you have to look at the answers in here and just like which of these answers is a primary alcohol. So you just notice that you have first one, you have number 1 on the first carbon, which means this is definitely primary alcohol. So the answer is A. If you look at this butanol, you have 4 carbons and you have OH in the second. If you make oxidation, it will change it to ketone. So this is not a good answer. It won't give any results with Tollens test. And here you have butane. You have OH group on the second and the third carbon. You have OHs. So if you make oxidation for these, you won't have aldehyde. You will have ketone for sure. For D, for example, here you have 2-methyl butane. You have 1, 2, 3, 4. You have 2 OH in here, and you have methyl group in here. So, by the way, this reaction is tertiary and it cannot undergo oxidation. So these are the wrong answers. This is the correct one. Okay. Let's go to the 25. 25 says, a student prepares butanol, which is alcohol, by alkaline hydrolysis of iodopentane. She gently warms the reaction for 20 minutes. So, by the way, this reaction is substitution. Yeah, this is a nucleophilic substitution in here, as we can see. You have primary halogen alkane, you add hydroxide ion with heating, and then you will get this product. When a student uses 1 chloropentane, okay, we change here the halogen. We use the chloro instead of iodine. To prepare the same alcohol, she has to change the condition of reaction. Okay, what a change in condition should she use, and what is the correct reason for this use? So first of all, you have to remember something. You'll have a carbon and halogen, and you have another carbon with Cl. Okay, so according to what you have, the halogen size here is larger than the halogen size of a chlorine. Okay, I just want to draw it smaller. The halogen size of a chlorine is smaller than the iodine. And this indicates here longer bond between carbon and iodine and shorter bond between chlorine and carbon. So according to what we have, in the first compound, we used 20 minutes for heating. But here, we want to make the conditions a little bit harsher. So we want, let's say, harsher conditions to break the bonds in here and just to make the reaction. So let's go and see the answers. Heat under reflux. Okay, we want to make reflux here because reflux in this case is a stronger way, or let's say make the reaction a little bit harsher or stronger so you can break the bond. Okay, we can cancel C and D because we don't do that at room temperature. We have stronger bonds than before. So we could have possible answers which are A and B. So let's go to the reason behind. It says that you have chlorine. CCl bond is more polar. No, it doesn't have anything in polarity. Both are polar, by the way. The most important thing in here, CCl bond is stronger than Ci. So the answer is B in here. We can say CCl is more polar than Ci. Yeah, actually it is. And it depends on the values of electronegativity. But the factor that plays a role here is the strength of the bond. It doesn't relate to the polarity. So let's look at this question. The malic acid is found in apple. This is the malic acid. And you just notice that it's composed of 2 carboxylic acids and 1 OH group or hydroxyl group. Which reagent will react with all 3 OH group present in malic acid molecule? Yeah, I just remember something, a pureful element that reacts, which is C, sodium. So once you react sodium, you need actually 3 moles of Na to react with these issues. Okay, yeah. Another type of questions that, let's say, come frequently, which is in 27, it says that cyclic esters are also known as lactones. So this is lactone. Delta lactone is used as a solvent in manufacture of polyesters. For which compound could delta lactone made by a single reaction? So first of all, if you once, let's say, face a certain type of this reaction, you will start thinking about, you have an open chain, okay, and then you will change it to a cycle like this. So the first step here is counting the number of carbons that you have in this compound. You have 1, 2, 3, 4, and you have 5. So you have 5 carbons. So this is the first step. And you just notice that the cyclization process takes place after the oxygen in here. So probably you will have a compound that looks like carboxylic acid. So we can say like you have C double bond OH, all right? And yes, this is the carbon here, and we will start the second carbon, CH2, the third, the fourth, the fifth. But in this case, you want to make a cyclization, you must add another group, let's say like hydroxyl group. So the hydroxyl group that you can add it must be bonded to this area. So in this certain type of reactions, you could have a carboxylic acid that ended up with OH group, so you can make a cyclization. So you could form that this O will attack this here, and this group will be gone, as we can see. Then you will have this compound. So first of all, what to do in this case? First of all, you have to look at the compound that contains a carboxylic acid in the side, and the other side it contains hydroxyl group, and it must be 5 carbons. So if we start with the first one here, you just notice that the group here, which is in the end, is aldehyde, so we cancel this because it's not our example that we need. Here we notice that we have a compound that ends up with carboxylic group, and we have OH, which might be good for us. And now it's time to count the number of carbons. You have 1, 2, 3, 4, 5. So this one works. So the answer here is B. If you count this here, by the way, we can cancel this because we don't have double bond in this compound. There is no double bond here. We have hydroxyl groups on the both sides. So we can cancel this. And if you look at this compound in D, it has 2 terminals, which is carboxylic acid and OH, so it might be good. But if you count the number of carbons, you can say 1, 2, 3, 4, 5, 6. This is not our target, so the answer is B for sure. Okay, the second one says, which reagent cannot be used to distinguish between ethanol and propanol? So we're dealing with aldehyde and ketone. Okay, this is a propanol, and this is ethanol, CH3, C double bond H. Okay, so let's start with the first one. Acidified sodium dichromate solution. It's the same as potassium K2, Cr2O7. It works as oxidizing agent. So if you make oxidation process, it won't be oxidized because this is ketone. And if you make oxidation for this, it'll change to carboxylic acid. Then you can distinguish, so we can cancel this. B says alkaline aqueous iodine. You just remember that this type of test is used to test whether you have this group, a carbonyl group that has a CH3. You notice that in both compounds, you have this group. So if you make this test for both these compounds, you won't get any difference in the results. Both have this group. So this reagent cannot be used to distinguish between the two. Okay, so the answer is B. Let's go and see this one here. The ester, this ester, you look at this one here. You have the C double bond here. You can translate it in a form that you can understand it. CH3, CH2. I'm drawing from here. CH2, C double bond. Okay, you have CH3, O, CH2. Okay, and you have another CH that is bonded to 2-methyl group. You have CH3 and CH3. Okay, so this is the ester. It says that it was hydrolyzed under acidic conditions. You will get them back to carboxylic acids and alcohol. So we'll take it here. This will change to carboxylic acid. And generally it's 1, 2, 3, 4. It's butanoic acid. And here it will change to to alcohol, you will have CH3, and you have H, CH2, and the OH is here, right? You put the OH in here. So if you start counting the number, or let's naming this compound, we start counting from the closest to OH, 1, 2, 3, then it's propanol, and you have a branch on the second, so this is 2-methyl, okay, propanol, propan, 1-ol. So which of these answers is correct? It says that what are the organic products of the hydrolysis? We have a butanoic acid, so we can cancel C and D. And what is the product of alcohol part? You have 2-methyl, 1-propanol, so the answer here is A. Question 30 says, general ethanoate is present in ginger and coca, and it's used in shampoos and soaps as a perfume. It reacts with excess bromine in inorganic solvent to give X, a bromo derivative, like the compound that comes as a result of this reaction. Including general ethanoate, how many cis-trans isomers are for this compound, and how many chiral centers are in X after reaction? So if you look at this one, when we say cis and trans, we're looking for a double bond, okay? And we're looking for different groups, like this carbon must be connected to different groups, and this one must be connected to different groups. So if you look at this one here, you notice that we have, yes, this bond have different, so you could have cis and trans, so you have two geometrical isomers. And if you look at this, you notice that this carbon is bonded to two identical groups, so we don't have cis and trans in this case. So the only possible answers, or let's say the possible numbers, is 2. We can cancel C and D, so we could have A or B. And now let's go what happens as a result of adding bromine atoms. So I'm going to erase all of this stuff in here. I just want to change it to like bond, normal bond, and we will have a bromine here. Once you add Br2, you will add Br in here and here, like on both carbons, Br and Br. So how many chiral centers we have? So if you look, starting from here, we don't have chiral because it's like atoms. We don't have because it's sp2 chiral, and we have two identical atoms, like two hydrogens, so it's not. If you look at this, yeah, this is chiral center. This is first one, yes, and this is the second one, yeah, and this is the third one, yeah. But if you look at this, you just notice that you have two methyl groups which are identical, so we don't consider this as a chiral center. So the answer is A.